Okay, just real quickly, one thing that you should have learned in probably an Algebra 2 class, maybe, are properties of inverses. And e to the x and the natural log of x are inverses of each other. So when I say e to the ln of x, I get back x. Or when I take the natural log of e to the x, I get back x. So that's just like an FYI thing that you should have learned in another class. So here I'm trying to do an example of an equation similar to what you should have going on. So if I have this equation, the natural log of y equals this, and I want to get y by itself, I call this eatizing both sides of the equation, meaning I want to take e to this power on the left and e to this power on the right. So that's what I'm showing down here, e to the ln of y. I'm using the property at the top, that leaves me y on the left, and on the right, I get e to the minus 5x plus 3. But using a property from, again, an earlier algebra class, e to the a plus b is also the same as taking e to the a times e to the b. So applying that here, I would get e to the third power times e to the minus 5x. E to the third is just a number. Put that in your calculator, you get a number. So the equation simplifies down to something like this. Now, this equation follows the general exponential model. This number here is an initial amount. Your question is asking about how much decay. So that's why for your problem, whatever this number ends up being, you take 1 minus the absolute value of that number, and that'll give you the answer that you're searching for. I hope that helps.